Hey everyone, in this video we're going to go through Autodesk ReCap, looking how to take busy laser scan models that look something like this and trim the data down into something a little bit more presentable. In this case, this is a floor flatness test. First thing you want to do is click on New Project and then click Import Point Cloud. And then first you want to name your project. This is going to be LL-2 restrooms, and then you want to navigate to a folder where you want to save this. Alright, then proceed. Now you just select the files that you want to import, the laser scans, the E57s preferably. So you select all those scans, so you click open, and then I leave all these settings as is. Go to the advanced tab. I always turn off decimation. My understanding, decimation, if there's multiple points kind of in the same location, it'll kind of take the average of those points and make them into one. We just like to keep all the points just because it's better to have more data. So then down at the bottom you click import files, and assuming your laser scans are already registered, go ahead and hover over the auto register scans. You can say skip registration, and then it'll take a couple minutes for it to load. And once those are all loaded, you just click on the launch project button, and there you go. Laser scans take another second to load, and now we have something that looks a little messier like this. So what we're going to do is go through how to clean it up a little bit. So the first thing I always do is click on the view cube. I just click on the top panel there, rotate it so that it's facing north, and then in the second tab down there's the eyeball icon, and then if you go to the perspective, turn it from perspective to orthographic. It doesn't actually tell you orthographic, that's what it is. It gives you a more realistic top-down view, kind of like what you see in Revit or Navisworks, has orthographic or perspective. And naturally, the selected tool will be this window icon. So all it is a selection window. So if you just take a selection box, so I always start with the outskirts, and it selects all these points, and there might even be smaller ones that are kind of hidden, too small to detect from being zoomed out this far, and I just delete them. And it actually doesn't necessarily delete the points, it more so archives them. There's a way to recover all of your points that you have deleted by going up to this top home tab, and then there's this recover deleted points icon there. So if you delete too much, this is a way to pretty much undo all of your deleting. So I'll continue here, still using my select box, grabbing all those points on the outskirts, doing the same thing here. Looks pretty clean for the most part, looking at a top-down view. And really all this data that you see that's kind of scattered, that's not really important. But for the sake of this video, I'm just going to leave all those points there. Looks like a nice clean square. So next we want to kind of do the same thing, flipping to one of the elevation views. So again, using that view cube. And we can delete all the points that are too high for what we're shooting for today, and all the points that are too low. Alright, so now it's generally pretty clean. You can see there's still some points that are probably lower than what we really want. At the end of the day, I'm making a floor flatness test, so I really want to delete everything except for just the floor at the specific locations where we're shooting the floor flatness. So now I'm just going to clean it up a little bit more. Alright, that's about as clean as we need to get for this exercise. One more thing I want to show you too is there's one more way to clean up, trim out the excess points in your model. If you use this fence option here, you can actually trim at different angles. So for instance, we have our stair right here. You kind of click once, click again, and it's kind of hard to see, but you can kind of see the selection box following me, and then you double click to finish out that cut. And instead of being a perfect square, you can just kind of make whatever shape you want. And something I always like to do after I clean up my base file, we'll call this one, is I want my team members to be able to see everything that we've laser scanned, as in they don't have to go out onto the site, or they can take measurements. I want them to be able to see all this context. So what I'll do is I'll save this as a base file. So all we need to do is go to the save icon here. Always want to click optimize 3D point cloud only, because if you select do not optimize, all those points that you deleted will pop back up. They will all publish. So you want to optimize it. And then all of this real view stuff we didn't mess with today, so I'm not going to get into that. And standard is fine. Now you just say OK. So now, as I mentioned earlier, I'm going to go through and clean it up even further so that I can get just the floor flatness of the 2 restrooms that are in this level. And lastly, now that everything's cleaned up, we will save as a different project. So I have the full scan in one folder, and then just the floor flatness in another folder. So I'll just give this one a slightly different ending. Instead of all, end it in FF. And then same thing, remove 3D point cloud only. Let me say OK. That's it for this tutorial, so appreciate you watching. Be sure to check out the next video on how to take floor flatness laser scans, throw them into AutoCAD to give you a heat map. So if you got any questions, just drop them in the comments.